Today we are going to discuss the need of metric space and need of topology in mathematics. So let's start with the definition of metric space. Let X is a non-empty set. A function d on x cross x is said to be metric or a distance function if d satisfies the following properties. The first property is positive property. The distance between 2 points A and B should be non-negative, and equality holds if and only if A is equal to B. The second property is symmetric property. That is, A distance between A and B is equal to distance between B and A. The third property is triangular inequality. What is that? The distance between A and C plus distance between C and B is always greater than distance between A and B. So DAB is called distance between A and B. So this is the definition of metric space. Now look at the real line. What is the distance between -1 and -2? We know that the length of this red segment is 1 unit. Therefore, distance between -1 and -2 is 1. But what is the distance function here? We can calculate the distance between -1 and -2 like this. -1 minus -2 taking mod and we get 1. So distance function is mod of A minus B. So in case of real line, the distance function is mod of A minus B. What about R square in two-dimensional space? Then distance between AB and CD is equal to under root of A minus C square plus D minus B square. Now we will see how distance between these 2 points is equal to this number. For this, look at this diagram. We have 2 points AB and CD. Now draw these lines. Length of this line segment is A because x coordinate of this point is A. Length of this line segment is B because y coordinate is B. Similarly, length of this coordinate is C because we have point CD, and length of this length of this line segment is D because y coordinate is D. Now, what is the length of this line segment? We will subtract A from C, this line segment. So length of this line segment is C minus A. Similarly, length of this line segment is D minus B. Then by Pythagoras theorem, the length of this hypotenuse is under root C minus A square plus D minus B square. Therefore, distance between 2 points is always is equal to this number. But this is not true in real life for everyone. Look at the diagram. Let from point A crow wants to reach at point B. Then he can fly from point A to B and his path is AB. At the same time, a man wants to reach to point B from point A. Suppose there is a river between these 2 points A and B. Then man cannot fly. Therefore, his path is from A to C, and after that from C to B. Therefore, distance between AB are different in both cases. A crow can fly, therefore moving from point AB to CD, crow will cover the distance AB, that is under root A minus C square plus D minus B square. But a man have covered distance AC plus CB, AC plus CB, that is C minus A plus D minus B. We can write it as mod of A minus C plus mod of B minus D. This distance is again a metric. Distance between AB and CD in case of human being is mod of A minus C plus mod of B minus D, and this is called taxi cab metric. Now there are some another examples of metric spaces. The first example is dxy mod of x cube minus y cube. Similarly, the second example is of discrete metric space, that is distance between 2 points is 1 when they are not equal. If they are equal, then distance is 0, and similarly there are many more examples. These spaces give us more general concept, the concept of topological spaces. These spaces are spaces in which we measure distance with open sets. Let, if possible, we have two open sets, one is A and second is B. Let x and z both belongs to B and B set contains in A. Let y belongs to A but not B. Then we can easily decide that point z is more close to x than y. Now, what happens if B is not in our topology? Then we have only set A, and these 3 points belongs to A, and we cannot decide z is more close to x than y because we have not B in our topology. Therefore, the distance of y and z from x is equal in this case. Because without B, we cannot show that z is more close to x than y. Introduce new space x where tau is called topology, which is collection of open sets of x to measure distance. Instead of metric t, we will use topology here. Now look at the arc of circle in a metric space. Because the distance of Q from point O, distance of P from point O, distance of R from point O is equal. That is why this is an arc of circle. But in topological space, this arc look like that. Because we measure distance here with open sets, therefore we cannot measure distance as perfect as in metric spaces. By the open sets, we measure that the distance between OQ and OP and OR are equal. Therefore, the arc of circle in topological space looks like that. Because sometimes we have not metric to show that these distances are unequal. Open sets shows that these distances are equal, as we check above in case of open sets A and B. We say that these two arcs are homeomorphic.